If you've ever felt like you're nothing more than a biological machine operating inside a cold, mechanical universe, if you've been told that your consciousness is simply neurons firing in electrochemical patterns, if you've quietly wondered whether your thoughts, your choices, your sense of I actually matter in the vast architecture of reality, then what I'm about to walk you through has the power to change everything. Because here's the part no one fully explained. You have been living inside a story that says consciousness is an accident, a byproduct, an emergent glitch that appears when matter becomes sufficiently complex. Atoms combine, molecules organize, cells evolve, neurons fire, chemicals cascade. And somehow, mysteriously, subjective experience appears. It's a clean story, it sounds scientific, it feels grounded, rational, safe. But here's the twist. For nearly a century, the very foundation of modern physics, quantum mechanics, has been pointing in the opposite direction. And the man who proved this mathematically was not a mystic, not a philosopher, not a spiritual teacher. It was John von Neumann, one of the greatest mathematical minds in history. A central figure in the Manhattan Project, the inventor of game theory, a foundational architect of modern computing, the reason every computer you've ever used works at all. In 1932, von Neumann published a formal mathematical proof that should have permanently shattered the purely materialist worldview. He proved, not philosophically, not metaphorically, but mathematically, that no physical system obeying the laws of quantum mechanics can collapse its own wave function. Let that sink in. No physical system can collapse its own wave function. Not a particle, not a measuring device, not a Geiger counter, not a laboratory apparatus, not even your brain, so what does? That's the question we're stepping into today. And I promise you, the answer is simple and profoundly uncomfortable. Let's go deeper. Imagine a radioactive atom sealed inside a box. According to quantum mechanics, that atom exists in a superposition. It is not merely that we don't know whether it has decayed. It is that it literally exists in both states simultaneously, decayed and not decayed at the same time. This is not ignorance. This is ontology. Now suppose you place a Geiger counter next to the atom to detect radiation. If the atom decays, the Geiger counter clicks. Simple enough. But here is where quantum theory refuses to behave intuitively. When the atom interacts with the Geiger counter, the superposition does not collapse. Instead, the Geiger counter itself becomes part of the superposition. Now you have an atom that is decayed and not decayed, a Geiger counter that both clicked and did not click. John von Neumann called this the measurement chain. You might think, fine. I'll connect the Geiger counter to a recording device. Quantum mechanics says that recording device now enters superposition as well. It both recorded decay and did not record decay. Connect that device to a computer. The computer enters superposition. It both processed decay and did not process decay. Connect the computer to a display screen. The screen enters superposition. The light from the screen strikes your retina. Your retina enters superposition. Electrical signals travel down your optic nerve. Your optic nerve enters superposition. Those signals reach your visual cortex. Your visual cortex enters superposition. Every physical system in the chain, no matter how large, no matter how classical it appears, obeys the Schrödinger equation. And the Schrödinger equation preserves superposition. The chain does not break, it cannot break, unless von Neumann concluded that the chain terminates in exactly one place, the conscious observer, the ego, you. Now I know what this sounds like. It sounds mystical. It sounds like pseudoscience wrapped in quantum vocabulary. But this conclusion did not come from a spiritual movement. It came from one of the most rigorously logical mathematicians of the 20th century, a man described by his peers as intellectually operating on an entirely different plane. Von Neumann valued formal proof above philosophical comfort, and his conclusion emerged directly from the mathematical structure of quantum mechanics itself. Let's clarify what he actually demonstrated. Quantum systems evolve according to the Schrödinger equation, a deterministic, reversible equation. If you know the wave function now, you can calculate it at any future time. But measurement does not follow that equation. Measurement introduces collapse, a discontinuous, irreversible transition from superposition to a definite state. Von Neumann showed that no physical process governed by the Schrödinger equation can account for collapse, because every physical interaction preserves superposition. If every physical system remains in superposition, then no physical system can explain why we experience definite outcomes. So what explains it? Von Neumann's answer was radical: the transition from physical system to conscious awareness, the abstract observer, the moment of experience itself. This is not mysticism inserted into physics. This is what happens when you follow the mathematics without flinching. Now here's where the story becomes even more fascinating. Erwin Schrödinger, the very physicist who formulated the equation that governs wave-function evolution, found these implications so absurd that he designed a thought experiment to expose what he believed was the ridiculousness of quantum theory. You know this thought experiment, Schrödinger's cat, but here's what most people miss. Schrödinger did not invent the cat to defend quantum mechanics. He invented it to criticize it. According to the measurement chain logic, if consciousness is required to collapse the wave function, then the cat inside the sealed box, rigged to die if the radioactive atom decays, must exist in superposition. Alive and dead simultaneously, not unknown, not hidden, but physically both. Schrödinger thought this was absurd. He was essentially arguing that if we take quantum mechanics literally, we arrive at a paradox so extreme that something must be wrong with the theory. And yet, nearly a century later, quantum mechanics remains the most experimentally verified theory in scientific history. Every prediction confirmed, every equation validated, every device built upon it functioning flawlessly. The screen you are looking at right now exists because quantum mechanics is correct. So we face a dilemma. Either consciousness plays a fundamental role in reality, or we require a radically different interpretation of quantum mechanics that avoids this conclusion. Physicists have tried many worlds: pilot wave theory, objective collapse models, decoherence, endless reinterpretations, but none of them eliminate one unavoidable feature. There is a transition from potentiality to actuality, from many possible states to one experienced outcome, from superposition to definiteness, and that transition appears inseparable from observation. Before we continue, pause and consider something personal. Where in your own life have you felt this shift, the difference between what could be and what is, between possibility and decision, between multiple futures and one lived reality? Hold that thought, because it gets stranger. There is a critical distinction we must now make, one that even many physicists blur: the difference between entanglement and conscious awareness. When the radioactive atom decays and emits a photon, that photon becomes instantly entangled with the Geiger counter the moment they interact. Instantly, not very fast, instantaneous. Bell's theorem and the experiments conducted in the 1980s confirmed that entangled systems exhibit correlations that do not propagate through space in the ordinary sense. They are not traveling. They simply are, but entanglement alone does not explain collapse. It explains correlation. It explains connection. It does not explain why one definite outcome is experienced. And that distinction may be the most important doorway in this entire discussion. We are not just talking about particles. We are talking about the structure of reality itself, and possibly the role you play within it. But here's the crucial point. Entanglement is not the same thing as awareness. When the photon becomes entangled with the Geiger counter, and the Geiger counter becomes entangled with the electronic circuitry, and the circuitry becomes entangled with the computer, and the computer becomes entangled with the display, and the display's photons become entangled with your retina, and your retina becomes entangled with your optic nerve, and your optic nerve becomes entangled with your visual cortex. All of that unfolds at the speed of entanglement. Instantaneous quantum correlation. No delay, no waiting, no gradual buildup, but your conscious awareness of the result. That does not happen instantaneously. Awareness takes time. Time for photons to travel, time for neural signals to propagate, time for electrochemical processes in the brain, time constrained by the speed of light and the finite speed of neural transmission. So here is the question that has haunted quantum mechanics for decades. Does the wave function collapse the moment a conscious observer becomes physically entangled with the measurement result? Or does it collapse only when the observer becomes consciously aware of that result? This is not wordplay. This is not semantics. This is a question about the fundamental architecture of reality. Because if collapse occurs at the moment of entanglement with a conscious brain, then the physical brain itself is somehow special. But if collapse occurs at the moment of conscious awareness, at the moment of subjective experience, then consciousness itself is what's fundamental. Either way, the observer cannot be removed. Let's make this sharper. Imagine two photons created in what physicists call an entangled twin state. These photons are perfectly correlated. If you measure one and find it polarized vertically, the other will be polarized horizontally. Not probably, not statistically most of the time, always, instantly, no matter how far apart they are. Alice takes one photon to a laboratory in New York. Bob takes the other to Los Angeles. They are separated by 3,000 miles. Alice measures her photon. She finds it vertically polarized. At that exact instant, faster than light could ever travel between them, Bob's photon becomes horizontally polarized. The correlation is established immediately. But here's the essential nuance. Bob does not know this yet. He cannot know it. Information cannot travel faster than light. Alice hasn't communicated her result. From Bob's perspective, before he performs any measurement, his photon remains in sewer position. He is not aware of its state. And yet, from the perspective of the quantum system, the correlation already exists. The entanglement is already real. This is the gap between quantum connection and human awareness. Now scale this up to Schrödinger's cat. The atom decays, a photon is emitted. The photon entangles with the Geiger counter. The Geiger counter triggers the mechanism. Poison is released. The cat dies. All of these processes cascade through entanglement, building correlations throughout the entire system. But you are outside the box. You are not yet entangled with the outcome. So when does the transition occur? Is it when you open the box and photons reflect off the scene and enter your eyes? Is it when your retina processes the incoming light? Is it when neural signals reach your visual cortex? Or is it at the precise moment you become consciously aware? The cat is dead. Different answers to that question produce radically different pictures of reality. If entanglement with any macroscopic system is sufficient, then the cat acquires a definite state as soon as it interacts with something large enough. This is roughly the spirit of the Copenhagen interpretation. It suggests collapse occurs when a quantum system interacts with a classical measuring apparatus. But if conscious awareness is required, then perhaps the cat remains in sewer position until you are not merely entangled with the outcome, but consciously aware of it. And this is not a closed case. This remains an active debate in physics and philosophy of mind. But here is what we can state with confidence. Consciousness cannot be cleanly removed from the story. Whether it is the physical brain of a conscious observer that introduces something unique, or whether conscious awareness itself is fundamental, the observer occupies a role that purely physical. Accounts struggle to eliminate, and that leads us to the most powerful objection of all, the one that seems at first glance to dissolve the mystery entirely. The robot argument. You've probably already thought of it. If consciousness is required to collapse the wave function, why not replace the human observer with a machine? Build a robot. No inner life, no subjective experience, no awareness. Just cameras, sensors, processors, and circuitry. Let it perform the experiment. Let it measure. Let it record. If the robot obtains definite results and interference patterns vanish exactly when expected, doesn't that prove that consciousness is unnecessary? This is the strongest challenge to the idea that consciousness plays a fundamental role in quantum mechanics. Because if a machine can do everything a human observer does, if it can perform measurements, record outcomes, and generate collapse, then awareness seems irrelevant. No mystery, just physics. And honestly, this argument sounds convincing. Construct a sufficiently advanced robot, program it to run quantum experiments, let it operate autonomously. If interference disappears when which path information is obtained, if definite outcomes are recorded, then consciousness appears superfluous. Case closed, except not so fast. Because hidden inside this argument is a subtle but devastating flaw. A flaw so precise that once you see it, you can't unsee it. And it doesn't rely on mysticism. It doesn't invoke the ineffable nature of consciousness. It rests on pure logic. Let's unpack it carefully, because this is where everything begins to click. This is where the quantum enigma intersects directly with free choice, your free choice. And this is why replacing you with a robot doesn't eliminate the mystery. It simply relocates it. So let's descend one layer deeper. Imagine we fully replace the human observer with a robot. The robot has cameras, detectors, processors, everything required to perform a quantum experiment flawlessly. Now consider the classic two-box setup. A photon enters an apparatus that places it into a superposition of being in box A and box B simultaneously, both boxes at once. The robot now has two experimental options. Option 1, the witchbox experiment. Open one box and check whether the photon is there. If it is found in one box, the superposition collapses. The photon is localized. Option 2, the interference experiment. Instead of checking either box individually, recombine the paths in a way that allows interference to occur. If interference is observed, it demonstrates the photon was in both boxes simultaneously. The robot can perform either experiment. And whichever it performs, quantum mechanics delivers the predicted result. So far, nothing strange. Now let's multiply the setup. Imagine hundreds, thousands of identical box pairs, each containing a photon in superposition. For each pair, the robot must decide which experiment to perform, which box or interference. Suppose the robot uses a randomizer, a coin flip. Heads perform the which box measurement. Tails perform the interference measurement. It executes the procedure perfectly. And the outcomes align exactly with quantum predictions. So where's the problem? The problem is not in what the robot measures. The problem is in how the choice of experiment is made. Because that choice determines whether reality manifests as particle-like or wave-like. And that decision, that selection, is not dictated by the quantum system itself. It originates outside the system being measured. This is where the mystery returns, because the quantum system does not decide which experiment is performed. The experimenter, human or robot, makes that choice, and that choice shapes what becomes actual. So now the question shifts, is the robot's decision truly independent? Or is it fully determined by prior physical states? If the robot's choice is fully determined by prior physical conditions, then the entire experiment, including the apparent collapse, is embedded in a larger deterministic chain. But if genuine choice exists, if there is true freedom in selecting which measurement to perform, then that freedom stands outside the deterministic evolution of the wave function. And this is the layer where free will and quantum mechanics intersect. Replacing the human with a robot does not eliminate the role of the observer. It forces us to confront the origin of choice itself, because the mystery was never just about measurement. It was about who or what decides how reality is interrogated. And once you see that, you realize the enigma hasn't been solved. It has only moved, and we are now standing at its deepest edge. Tails means interference. The robot flips the coin, heads. It performs the witchbox experiment on pair number 1. The box is opened. The photon is found in a single box. Clear, definite, localized, good. Pair number 2. The robot flips again, tails. This time it performs the interference experiment. The paths are recombined. An interference pattern appears, unmistakable evidence that the photon was in both boxes simultaneously. Good. Pair number 3, heads, witchbox experiment again. The photon is detected in one box, and so it continues. Flip, measure, record, flip, measure, record. Everything behaves exactly as quantum mechanics predicts. The robot performs the experiments flawlessly. No consciousness involved, no awareness, no subjective experience. Problem solved, right. Not quite, because here is where the logic becomes uncomfortable. For the interference experiment to succeed, for an interference pattern to appear, the photon must have remained in superposition the entire time. It must have existed in both boxes simultaneously. But for the witchbox experiment to succeed, for the photon to be found in only one box, the superposition must have collapsed into a definite state. These are mutually exclusive requirements. One demands maintained superposition. The other demands collapse. They cannot both be true for the same event, so now we must ask a deeper question. How does the photon know which experiment the robot is going to perform. How does reality determine whether to preserve superposition or collapse it, based on a coin flip that has not yet occurred? Let's slow this down and make it absolutely clear. If the robot flips the coin and gets interference, then the photon must have been in superposition all along, both boxes at once. If the robot flips the coin and gets which box, then the photon must have been in only one box. But here's the tension. The photon enters the apparatus before the coin is flipped. The decision comes after the quantum system is already in motion. So how does the photon align its behavior with a future decision? There are only a few logical possibilities. Possibility 1, the robot's coin flip is not truly free, it is predetermined. The universe already knows what the robot will choose because everything, robot, coin, photon, apparatus, is unfolding deterministically from initial conditions set at the Big Bang. No true randomness, no free choice, just an inexorable chain of cause and effect. If this is true, then the photon's state is also predetermined. The entire experiment is a single scripted unfolding. There is no real enigma, no paradox, no mystery. Reality isn't responding to observation, it's just dominoes falling. Possibility 2, the robot's choice is genuinely random, true quantum randomness. Not predetermined, but now we face something even stranger. If the choice is genuinely random, if the future coin flip is not fixed in advance, how does the photon correlate perfectly with that future random event? How does the system align with a choice that hasn't happened yet? This begins to smell like backward causation, the future influencing the past, and that is not a trivial adjustment to physics. Now here is where everything shifts. Replace the robot with a human being. Replace the mechanical coin flip with you. You stand before the apparatus. You decide which experiment to perform. And in that moment of free choice, something profound occurs. By choosing the interference experiment, you establish that the photon was in both boxes. By choosing the which box experiment, you establish that the photon was in only one box. These are contradictory realities. Both cannot be simultaneously true. Yet your decision determines which reality manifests. This right here is the quantum enigma. It does not arise from a mechanical process. It does not arise from a deterministic script. It arises from agency, from the act of choosing, from free will. A robot running a pre-written program does not generate paradox. It generates correlation. We can wave it away with determinism. But a conscious agent making a genuine free choice introduces something radically different. You establish one of two mutually exclusive pasts. Not just different futures, different descriptions of what the photon was doing before you measured it. And that is why consciousness cannot be cleanly removed from the quantum picture. Not because consciousness is magical, not because minds shoot beams into particles, but because free choice is what gives rise to the enigma in the first place. Without free choice, everything reduces to mechanical unfolding. With free choice, reality becomes paradoxical. Now let me clarify something important. I am not saying your consciousness magically controls quantum particles. I am not saying you can manifest sports cars through sheer intention. I am not saying the universe rearranges itself to match your wishes. What I am saying is this: the relationship between observer and observed in quantum mechanics is not incidental. It is not a glitch. It is not a temporary flaw waiting to be engineered away. It appears to be structural, fundamental. John von Neumann showed mathematically that no physical system can collapse the wave function. The chain of quantum correlations extends through every detector, every circuit, every device unbroken, until it reaches the conscious observer. Schrödinger found this so unsettling that he created the cat paradox to highlight the absurdity. Yet nearly a century later, we still cannot escape the implications. The robot argument attempts to eliminate consciousness, but it fails, because a robot executing a predetermined program does not generate the quantum enigma. It simply executes mechanical correlations. The enigma emerges when free choice enters the equation. Your free choice, that is what establishes contradictory realities. That is what forces us to confront something deeper than mechanics. So where does this leave us? It leaves us staring directly at the foundations of the materialist worldview. For centuries, science has operated on a pyramid of reductionism. Psychology reduces to biology. Biology reduces to chemistry. Chemistry reduces to physics. Physics sits at the base, the ultimate layer. But quantum mechanics reveals something astonishing. Physics itself appears to rest upon observation, and observation involves consciousness. As one physicist famously remarked, we may have to add cloudy consciousness to the base of the reductionist pyramid. Consciousness may not be something that emerges at the top when matter becomes sufficiently complex. It may be woven into the foundation itself. This does not mean abandoning science. It does not mean discarding rational inquiry. It does not mean embracing mysticism uncritically. It means expanding our framework to include what the mathematics and experiments are actually pointing toward. From von Neumann's formal proof, to Bell's theorem, to decades of experimental confirmations, the pattern is consistent. The observer cannot be removed from the observed. Consciousness and reality are entangled, not metaphorically, not poetically, but structurally within the mathematical fabric of the universe. Now, does this mean you can collapse wave functions at will and redesign your life? That is a separate question, a practical question, and the honest answer is, we do not yet fully know. But we do know this: you are not a passive spectator in a mechanical cosmos. You are not merely an accident of chemistry with no agency. You are a conscious being whose observations appear to participate in the unfolding of reality itself. And that changes everything. So what does this mean for you? For how you live? For how you choose? If consciousness is fundamental, if observation genuinely plays a role in the transition from potentiality to actuality, then the story you've been told about yourself is incomplete, at best. And at worst, fundamentally wrong. You are not a biological robot executing genetic code inside a predetermined universe. You are something far more participatory than that. You possess agency, not as a poetic metaphor, not as a comforting story we tell ourselves to feel empowered, but as something real. Something structurally embedded in the architecture of existence itself. Your choices matter, not because of a motivational slogan or spiritual cliché, but because free choice is woven into the very fabric of the quantum mystery. It is free choice that gives rise to the Enigma. It is free choice that allows contradictory potentials to stand side by side, unresolved, until reality is compelled to settle into one definite expression rather than another. This is the point where many people misunderstand the implications. They hear the phrase, consciousness collapses the wave function, and immediately leap to the conclusion that they can manifest whatever they desire simply by concentrating hard enough. That is not what the science is claiming. The research does not suggest that wishing intensely bends the universe to your preferences. What it indicates is something far more nuanced and far more profound. It suggests that observation, conscious observation, appears to participate in the transition from quantum possibility into classical actuality. But participation is not the same as domination. It does not imply that your personal cravings dictate outcomes. It does not mean the cosmos rearranges itself on demand to satisfy your intentions. What it does mean is subtler, and in many ways, deeper. It means you are involved in the unfolding of reality itself. Not as a puppet master controlling every thread, but as a participant woven into the tapestry. There is an enormous distinction here. Control implies force. It implies bending reality to your will, manipulating outcomes, asserting dominance over a mechanical system. Participation, on the other hand, implies relationship. It suggests partnership. Co-creation, a reciprocal exchange between observer and observed, a dynamic interplay rather than a one-sided command. And here is the elegance in that realization. When you understand that you are participating rather than controlling, something inside you softens. The strain eases. The frantic grip on outcomes begins to loosen. You stop trying to strong-arm a mechanical universe into compliance. Instead, you recognize that reality is not a lifeless machine, but something interactive, something responsive, something far more alive than strict materialism ever allowed. This is where quantum mechanics begins to intersect with insights ancient traditions have been hinting at for thousands of years. You are not separate from reality. You are interwoven with it. Your consciousness is not merely watching the universe unfold from a safe distance. It is implicated in the unfolding itself. Now, does this mean you can instantly cure disease, summon wealth, or override physical laws through sheer intention? Almost certainly not. But does it suggest that your awareness, your focus, your decisions exert genuine influence in shaping the reality you encounter? The evidence increasingly points toward yes. And that realization carries two edges. It is liberating because it affirms that you matter. Your awareness is not a cosmic accident. You are not an irrelevant byproduct in a meaningless universe. You have authentic agency in a cosmos that appears to respond, at least in part, to observation. But it is also unsettling, because agency brings responsibility. If your choices contribute to the establishment of reality, then you cannot hide behind strict determinism anymore. You cannot shrug and say, "It's all just chemistry. I'm not really choosing." The quantum picture refuses to let you off the hook so easily. You are choosing, and your choices play a role in which realities become actual, so choose carefully. Choose deliberately. Choose with a full appreciation of the profound role you inhabit in this intricate quantum dance. Let's gather everything together. We began with a question: does consciousness collapse reality? From there, we examined the arguments. Von Neumann's mathematical reasoning, suggesting that no purely physical system can fully account for wave function collapse. Schrödinger's cat and the absurdity of imagining macroscopic objects suspended in impossible superpositions. The difference between entanglement as a physical correlation and conscious awareness as something categorically distinct. The robot argument and its failure to remove consciousness from the explanatory framework. Every route we traced converged on the same uncomfortable insight. Consciousness occupies a place in quantum mechanics that resists elimination. It cannot be neatly reduced. It cannot be dismissed as irrelevant. It cannot be explained away simply by building more intricate machines or inventing more elaborate physical descriptions. Now, this does not hand us a finished theory. It does not pinpoint the precise moment collapse occurs. It does not clarify whether it is the biological brain that matters or awareness itself. It does not provide a practical manual for manifestation or personal transformation, but it does reveal something significant. The materialist narrative, the story claiming you are nothing more than atoms obeying blind physical laws, that consciousness is a fluke, that free will is an illusion, that story is incomplete. Quantum mechanics itself strains against it. What replaces it is not superstition, not blind faith, not a rejection of science. Rather, it invites an expanded scientific perspective, one that treats consciousness as a fundamental feature of reality instead of a secondary byproduct. One that recognizes that observer and observed are entangled in ways we are only beginning to comprehend. One that is willing to admit mystery without abandoning intellectual rigor. This is the quantum enigma, and perhaps it is not a puzzle to be solved once and for all, but a reality to inhabit consciously. You are a conscious presence in a universe that appears to respond to observation. That is not mystical fantasy. That is embedded in the structure of quantum theory. You exercise free choice, and those choices correspond to mutually exclusive realities that must resolve into one outcome. That is not abstract philosophy. That follows directly from the logical implications of the robot argument. You are not separate from what you perceive. You are participant. You are co-creator. The evidence keeps pointing in that direction. So what follows from this? You begin to live with awareness. You make choices intentionally. You observe knowing that observation itself is not trivial. You stop pretending you are a detached spectator drifting through a mechanical cosmos. You stop using determinism as an excuse to disengage. You step fully into your role as observer, as chooser, as conscious presence participating in the unfolding of reality. Does this guarantee specific results? Does it mean you command the universe? Certainly not. Does it imply that your consciousness carries significance beyond what strict materialism could account for? Yes, and that realization alters how you move through the world. It changes how you approach decisions. It reshapes how you relate to possibility and to actuality. It reframes your understanding of what it means to be here at all. So ask yourself, where in your life are you ready to inhabit this role more completely? Where are you prepared to observe with deeper awareness, to choose with greater clarity, to participate with fuller presence? Sit with that question. Let it resonate. The answer may carry more weight than you expect. If something shifted in you while engaging with this, if there was a spark of recognition, if the quantum enigma suddenly felt intimate rather than abstract, you are not isolated in that experience. There is a growing number of people recognizing that consciousness is not a random accident, that we are not merely biological automatons wandering through a dead universe. Even science, particularly quantum mechanics, is gesturing toward a view of reality that is participatory, relational, alive. This is episode 29 in the Observer Effect series. And the next step goes even further. In episode 30, we will explore a provocative possibility, perhaps the only objective evidence that consciousness exists in the first place. Not subjective reports, not philosophical speculation, but experimental indications that awareness itself interacts with physical systems. You can find the details and the full series in the description. If you want to continue exploring, subscribe and join the journey. And in the comments, leave a single word, just one, that captures how this landed for you. Until next time, observe with awareness, choose with freedom, participate completely. You matter more than you realize.